Welcome to Chill Skills Sporlan Tech Talks. The topic for this episode is supermarket methods of temperature control, EEVs, controlling discharge air temperature, and maybe even superheat. Thank you all for joining us. This is the 14th, if I recall correctly, in a series of presentations that will follow the agenda of the old supermarket seminars. You know, John, pretty soon I'm just going to stop trying to count these because I'm going to have to take my shoes off. In the past,
that would be awkward. Yeah, don't do that.
I won't do that. But you know, in the past, Sporlan had a team of professionals on a supermarket team that went around the country to facilitate these presentations in person. With this entry, we're bringing the supermarket seminar concept back, and hopefully we're getting to a wider audience in the process. John, you know, if we were still doing these in-person specialists and supermarket seminars, we'd really need a really large room in order to maintain that 6-foot clearance between everybody.
Indeed, we would.
Yeah. Well, hopefully everyone's staying safe out there. Now, this is a point where we usually tell you what's coming up next. When are we going to do the next webinar? Well, we're going to be taking just a short break so that we can get everything scheduled out and have new episodes lined out for next year. That means for now, happy Halloween, happy Thanksgiving, Merry Christmas, happy holidays, and maybe even happy birthday if it applies to you. I sent this happy birthday to my daughter-in-law last week. She didn't think that was very funny.
Oh.
I thought it's hilarious, but we will keep you posted on what we're going to do next when we hope you'll join us. Here are a few simple instructions. If the speaker on your computer doesn't work, you can simply dial in with your phone. There should have been a phone number somewhere on the invitation that you originally received for the webinar, but it's here on the slide just in case you don't have it handy. As we move along and you have questions, you can type those questions into the Q&A window, and we plan to answer those questions live as best we can. If we run out of time, we'll eventually post answers to the questions online. And believe me, eventually we will do it. However, if you hang on, there's a good bet that we may very well answer your question during the course of the webinar itself. And just so you know, the webinar is being recorded. This and all the others. You can go back and listen to them. They'll show up on Facebook Live first, like this one, for instance, and then later on Sporlan YouTube, the Sporlan video.
Sporlan video
on YouTube.
Channel on YouTube.
Yeah.
Yeah, that one.
So go back and listen to them. Hello, I'm Jim Jansen, Senior Application Engineer for the Sporlan application team. That's me on the left. I guess that's right there. And joining me today is John Whithouse. John, did you miss me?
I did. But my aim is improving.
It is. Good. Well, eventually. John is the Senior Principal Engineer for the Sporlan division. He's a published author, consultant. And I hate to have to say this, he's an all-around extra smart guy. John's a pretty big deal around here, and it has nothing to do with his weight. We're really excited to have him with us here today. Say hi, John.
Good afternoon, everyone.
And Phyllis is in the room. She's our communications director. She tells us what to do and when to do it, like when to advance slides and when to not advance slides and when to talk and when not to talk, and every once in a while we listen to her. If you have any follow-up questions or feedback, you may contact us via email or contact the Sporlan technical support team at svdtechsupport@parker.com. You can always call 636 area code 239-1111. That's a general number for our headquarters. And that can get you into applications as well as tech support if you need it. Also, you'll see our direct email addresses underneath our name, and you're always welcome to send an email to us directly.
Indeed.
Here is an application of the basic refrigeration cycle in the form of a DX multiplex rack. And it looks quite complicated. But just remember, there are only 4 primary components in every one of these systems, consisting of compressors, 1 or more compressors, the condenser, multiple evaporators perhaps, and the metering device. But today we're going to zero in on this section of the system. And we're going to continue our discussion on temperature control. We have previously discussed these other methods of temperature control. This is the final discussion that we're going to have on this subject. And today we'll cover EEVs being used to control discharge air temperature, and even superheat. Some controllers have the ability to control an EEV to not only a desired discharge air temperature, but they can also monitor the evaporator's superheat. Superheat is a safety to protect the compressor from liquid damage. Some common vapor compression refrigeration systems actually use this control method. We haven't dealt with the aspect of controlling pressure with this technique, and there is some concern that operating a case at common suction pressure will cause perhaps additional frost, odd frost patterns, maybe impact the humidity level in the case. I guess we'll see.
We shall.
We have included this slide simply for reference. In comparison to a mechanical EPR, this option with the electric EPR requires a controller of some type to accept the discharge air temperature reading from sensors, either a temperature sensor, a pressure transducer, and things of that nature. You see a temperature sensor here, a pressure transducer, and by signaling the electric EPR into a closing direction, the pressure will increase and cause the discharge air temperature to also increase, while the thermostatic expansion valve over here controls superheat at the bulb. That's one of those pesky little wireless superheat controls, right, John?
Correct. They are wireless.
Wireless.
TEVs are completely wireless.
In this example, we have depicted the Kelvin-style control device. There are multiple Sporlan videos on YouTube that discuss this control in detail. Covers things like how to select it, how to install it, how to set it up. Regarding controllers, Sporlan offers a standalone controller to drive the EEV and the electric EPR. Here are some examples: the temperature control and pressure control in the Kelvin series, and also some case controllers as well operate as standalone controllers. More commonly, EEVs and EEPRs are controlled by dedicated boards or case controls that communicate with the store's BAS, building automation system. This allows the technician to see and monitor case temperature, valve position, and the list goes on. And this can take place from the controller or from even a remote location.
Absolutely.
That's the really neat thing about these is you can monitor things remotely.
Yep. Remote monitoring, remote changing of settings, a lot of options available there.
As much as I like mechanical valves, you have a tough time doing that with them.
You would. You need a really, really, really long screwdriver.
Fair enough. When an EEV is in the system, you're going to need something to tell it what to do. Here's an example of an appropriate controller for just such a task: the S3C case controller. That stands for safety, service, and security. That's kind of cute and catchy, isn't it, Joe?
It is. It's very catchy, I think.
I would have never thought of that.
No, me either.
We offer a complete online training class that covers this particular control. This case controller drives the EEV, the EEPR, and/or liquid line solenoid valves, and it also has onboard relays to control the lights, defrost cycle, fans, and anti-sweat heaters. We're not necessarily, we're using this as an example for all of the schematics that we're going to show as this proceeds. The Sporlan S3C case control product lines includes the case controller, a display module so you can see what's going on, and a valve module, and that all support open protocol communications via things like BACnet and Modbus. This display module also has Bluetooth. I used to think you had to go to the dentist to get that taken care of.
Not anymore.
Apparently not.
Not anymore.
These devices are designed to facilitate both installation and integration by the original equipment manufacturer or by even a contractor in the field as a retrofit project. And that's a really neat thing to be able to do.
Very much.
They lend themselves to that. That's pretty cool. The S3C case controller is capable of controlling and monitoring single temperature, single evaporator, self-contained refrigerated fixtures. In this example, one controller can do the job since we are only using a single EEV, as we see right here. When we include additional electrically actuated, electronically controlled valves, that valve module might become necessary. In fact, it's an extension of the case controller, and it'll make things like that possible. The controller will also control all typical case functions and receive the desired sensor inputs and drive the EEV. This control method would allow the EEV to regulate superheat. The controller would also drive the so-called optional liquid line solenoid valve to successive open and closed positions and open and close the EEV to control case temperature. This would be accomplished using the traditional cut-in, cut-out method. And the liquid line solenoid valve is listed as optional since refrigerant flow may actually be stopped by closing the EEV. But I kind of like the idea of including this solenoid valve, and I'm not so sure about the optional part. What do you think about that, John?
Yeah, I don't think we should really consider them optional.
Why is that?
Well, in the event of a power failure, the EEV is going to stay in the exact position that it was at the moment of power failure.
Oh, okay.
And so it's going to keep flowing refrigerant whether the case needs it or not.
Okay, I got it.
And so you could have some issues with flooding there.
Well, here's the thing. The power never fails.
Of course.
So it's optional. Here's a detailed view depicting recommended temperature sensor and pressure transducer locations with the suggested spacing between the components. Here you can see the pressure transducer and the various temperature sensors for things like coil outlet, discharge air, return air, defrost termination, and you can see the assigned color coding that Sporlan has decided to use for these devices. And you can see the spacing like we're depicting 1 to 2 inches here between the pressure transducer and the coil outlet sensor, and then 10 to 14 inches away from the surface of the evaporator coil itself for this particular one.
Correct. There are more details, of course, in application and product bulletins on these. This is a good overview.
Right.
Of this kind of gives you the basics of how this all needs to be oriented and set up inside your actual application.
Yeah, I'm glad you mentioned detail. Here's some detail. Yeah,
Wow,
this is
that is detail.
You like that? A relatively simple wiring diagram for this method of temperature control. Note the power supply, the display module, the liquid line solenoid valve, the EEV, all these temperature sensors, the pressure transducers hiding over here right there, and of course the case controller itself. And it's going to take inputs and control things like fans, lights, the defrost contactor, and so on. Mm-hmm. Pretty neat. In this example, the case controller and one valve module are required. The valve module is essentially an extension of the case controller and expands the controller's capabilities. Here's the valve module right here. This provides for additional input and outputs like the control of perhaps 2 EEVs or 1 EEV and 1 electric EPR. In this case, it is needed for the second EEV. The case controller will control the typical case functions and collect the desired sensor inputs and drive EEV1, as you see here in this example. The valve module will collect the necessary inputs for the second evaporator and drive EEV2. John, you act like you want to say something.
You know, Jim, we have an interesting question here.
Can you answer it?
I think we can answer it.
Oh, okay. Shoot.
The question is, in lieu of a pressure transducer, can a temp in and temp out method be used for control of superheat? And
you go for it.
Me go for it.
Yeah.
All right. That is an interesting question. So temperature superheat versus pressure temperature superheat.
Yeah. Okay. You know my feelings on that.
Yeah. In a world where we had nothing but pure single molecule refrigerants like R22.
Yeah. Now, John, you don't have half an hour to answer this question.
I know.
You know that, don't you?
I know that. I understand. So in that world where we had single molecule refrigerants, that worked, but didn't necessarily work very well, because in the real world, you have things like pressure drop through coils. When you have both pressure drop through coils and temperature glide, as you get with a lot of our zeotropic blend refrigerants today, temperature superheat is a very risky way of doing it. You're going to lose a lot of accuracy, and you're probably not going to have good results.
Pressure temperature is the right way to do it.
Pressure temperature is the right way to do it.
Awesome. And again, the EEVs in this particular example will regulate superheat by using that temperature pressure approach.
Correct.
The controller will energize the optional liquid line solenoid valve, again through successive opened and closed positions in conjunction with the EEV, to control case temperature with that cut in and cut out method. You can always go back later and take a look at the sensor and transducer detail on the previous slide when you review the recorded version on YouTube or Facebook. Typically, coil out temperature sensors would be installed on each evaporator coil outlet with one pressured transducer on the common suction. But I kind of like the idea of having two pressure transducers, as we show here in this wiring diagram for this particular example. Again, the valve module simply extends the input and output capabilities of the single case controller. And likewise, the EEV is connected to the valve module, and EEV1 and all the sensors and related devices are connected to the case controller. And we have included that second pressure transducer right here. Now, here's an example with 3 EEVs. Same kind of deal. You're going to need the valve module, because that extends the termination points and the ability to handle input and output that limits the S3C case control.
Right.
And here we've depicted, again, it looks like there's an undue amount of detail here, but really it's quite simple, this wiring diagram. We've got the S3C case control. We have the valve module, which extends its capabilities. And you can see here that we have 2 EEVs terminated, pressure transducer, and the solenoid valve. And then, of course, over here is the display module.
Correct.
Now, even though the EEV can influence both discharge air temperature and evaporator superheat, multiple evaporators running at temperatures above common suction just might show enhanced performance if we included an electric EPR. The case shown in the diagram below could be the lead case in a lineup. In this example, 1 case controller and 1 valve module are required. The case controller will handle the normal case functions and receive the necessary sensor inputs for the EEV. The valve module here will drive the electric evaporator pressure regulator. The EEPR will regulate discharge air temperature, and the EEV will control superheat. The optional liquid line solenoid valve may be installed as a 1 per case or 1 per lineup. Each case in the lineup could then theoretically be fitted with its own EPR and valve module. We'd like that because we get to sell a lot of valve modules.
We would indeed.
You know?
What that would enable is individual control of temperatures, of course, up and down that lineup for different types of product within that lineup.
And that's really gives you some flexibility.
It gives you flexibility, absolutely.
So that's something that you should scrutinize, whether you're setting it up with a Sporlan S3C case controller or you're using some other manufacturer's device, is look for that flexibility. Now here's the detailed wiring diagram. Very similar to what you've seen so far. You see we have EEV1 terminated on the S3C case controller. We have the electric evaporator pressure regulator terminated on the valve module. And then, of course, the power supply in each case, the display module, the solenoid valve, and all the other accessories. I got to say, if you plan to surface any of our electrically actuated, electronically controlled valves, the SMA-12 is an invaluable tool to have at your disposal. It is a self-contained, compact step motor actuator. It acts like a little controller. It can be used to drive these valves, and it is an excellent troubleshooting aid. And you just simply need to be careful with it because they're terribly elusive and they can disappear from a job site if you take your eyes off of them.
Yes, they can. They are. It seems like they can grow legs more easily than just about any other device you can imagine.
Yeah, we've noticed that they go missing, so to speak, quite frequently.
Yes.
But typical troubleshooting techniques involve having this kind of information at your disposal, and the SMA-12 will just extend your capabilities of troubleshooting a system if you're having difficulties. Likewise, a simple tool, the volt ohm meter, can be used to assess the integrity of these step motor driven valves. Different valves in our lineup have a different level of resistance. John, I was going to say ohmage in honor of George Ohm, but he doesn't get that credit, like
that's right.
Amps, amperage, volts, voltage. He's kind of gotten the short stick in that deal. But you notice here we have some valves that have a 75 ohm resistance level across the leads. You would check that in pairs, white and black, red and green. And in between opposing pairs, you would have an open circuit. You should have an open circuit to the body of the valve itself.
We should hope.
You should hope if you want it to work.
Yes.
And then you notice we have 100 ohm resistance motors in several of our valve lines. Now, how well does this work?
That's the real question. How well do these different methods work?
That's the real question. Now, we've covered 4 of them so far.
Correct.
This is the latest one. Now, we've included a little bit of detail on a particular SCR step motor valve option. It has the neat little 3427 inlet strainer fitted to it. That's a nice little option because contamination is the culprit of almost all of our products. The only things that really belong in a refrigeration system are
refrigerant and oil.
Well, okay. I kind of like lubricant, but yeah, oil, lubricant.
Okay, lubricant.
Yeah, this helps. It's an aid to help keep some of the hammer handles and lunch boxes out of the workings of this valve.
True. And maybe even a few copper shavings and a little bit of copper oxide and things like that.
Could be a good thing. Now, here's a log of data that was acquired on a system with a 4-door freezer. The graph displays case temperature in degrees Fahrenheit, discharge air temperature, if you will, as time varies. As you can see, the temperature fluctuates approximately plus or minus a half a degree over time. It tracks fairly consistently with the set point that was established, and it recovers fairly quickly after a defrost cycle.
Yep.
This is a pretty efficient way to control temperature. Now let's compare this performance method with some of the other methods that we have discussed during past webinars.
So this one looks pretty good.
Yeah, if you like this approach, then you've got a good option here.
That's right. That one looks pretty good.
Here's a version that we utilized at a previous time. How well does it work? This is the log of data that was acquired on a system with an electric evaporator pressure regulator. It was a medium temp system. Again, this graph displays case temperature, discharge air versus time. Set point here was around 37 degrees. As you can see, this is pretty similar to the other version. It's going to vary about plus or minus a half a degree over time. Again, it tracks the set point nicely and recovers quickly after a defrost cycle. Another very efficient way of controlling.
And very effective.
Now here is the mechanical EPR. This is a log of data that was acquired on a system with this type of pressure regulator. Again, it was a medium temp system. We have discharge air temperature as time varies. The set point was around 36 degrees Fahrenheit. It varies about plus or minus 1 degree over time, which is not bad. It's just not as good as the other two methods.
Correct.
It's a reasonably efficient way to control, and it's used still quite ubiquitously, if that's a $10 word I can use. I don't think we got any accountants listening today, so I can use big
correct.
words,
You
right?
can use that word. Yeah, you're right. It is a very popular method. Many mechanical EPRs out there, and they are effective. Good control. Maybe not as good as you can achieve with electronic devices, but still good control.
Reliable. Now, the thing you can't do with it is remotely monitor it.
Right.
Now, we started this series of discussions off with the liquid line solenoid valve and thermostat as controlling devices. And you can see here there's quite a bit of fluctuation in this technique, plus or minus 3 degrees. Varies a significant amount. If you're satisfied, though, with this level of accuracy and it works in your store or your facility, it may be perfectly acceptable. It works. It's just an interesting comparison. Mm-hmm. You have options. You pay your money and you take your pick.
Right. As an engineer, this doesn't look quite as pretty to me as the other curves do, but that's not to say it can't be effective.
Yeah. For all practical purposes, this is what you're doing with a lot of residential air conditioning systems, isn't it, John? Is that kind of
Very
what you're
true.
doing with that?
Yep. Very true.
No. Well, I got to tell you, we answered one interesting question. Do we have any others that we ought to address at this point? You can type those questions into the Q&A window. John will pick them up and we'll try to answer them.
At this point, I don't know that we have any more that we really should answer.
Okay. Well,
online.
It would take you a half an hour to answer them anyway, so we don't have that much time.
No, we don't. That's true.
That's a good thing. Again, this is being recorded and you can go back and listen to it first on Facebook and then later on YouTube. We're wrapping this up. Sporlan is always here to assist you with your air conditioning and refrigeration flow control needs. You can reach us by calling the general number for Sporlan headquarters at 636 area code 239-1111. We got a direct dial here for tech support. We actually have humans located in Washington, Missouri, and that's in the United States, that will help you with problems that you might encounter. If you call the general number, you can get access into not only tech support, but customer service. And of course, you can utilize their email address here. And we're here 24/7 on Sporlan.com, where you can access tech support, product literature, training material, sign up for our newsletter, go back and look, find a link to those product videos, various events, new product releases, and we've got this new virtual engineer software platform for sizing and modeling our products. And John, you had a lot to do with that.
I did. That is our online product selection tool. It uses very much the same sizing methods as our legacy Sporlan selection program that a lot of our longtime customers are very familiar with. But the new one is very user-friendly and can be run from any device. The old one pretty much had to be installed on a PC. Anything that can run a web browser now, you can size and select our products.
Perfect.
So even down to a phone.
We're going to do a webinar on that later. I can just see it right now, but you're going to have to stop talking now.
Really?
Yeah.
I really like talking.
You're going to have to just go back and listen to what we had to say on Facebook or YouTube.
If you insist.
I do.
All right.
Oh, wow. Sounds like a fire alarm's going off. That's wonderful. This concludes our webinar on methods of temperature control, EEVs and discharge air temperature, and sometimes superheat. Thanks for completing another Sporlan Chill Skills Tech Talk.
Do you smell smoke?
Maybe. We'll see you soon. You all stay safe.